Our next speaker is from Merck, Guttikonda. Sai is going to tell us today about his journey as part of the Merck manufacturing division with the Allotrope simple model format. And his title of his talk is Instrument Integration to Knowledge Graph Development Journey to Enable Seamless Flow of Data in the Laboratory Space with Allotrope. So I'll turn it over to Sai.
All right. Hey everyone, thanks for the opportunity to speak here. So there are a couple of fancy words in here in today's presentation. One is the knowledge graph and the other one is the journey. The reason I put a journey is because we are very new to Allotrope. This is our first visit here to this conference too. And we are like few months into this whole Allotrope journey. We've been aware of the Allotrope in the past, but we never got a chance to implement it in the past in our digital journey. But right now we're taking a new step into this whole AI thing. So we would like to, use Allotrope as our go-to standard for our instrument integration. So the main idea today here is to present our journey. This is going to be a continuous process. Probably we might come here every yearly or like bi-yearly for your conferences and probably present our progress, share our progress, our limitations, or things like that that we learn across the entire journey for a period of time, so that if anyone is on the same boat, you might also learn something from us instead of going through the path and facing the same challenges as we did in this process. Okay, let me introduce a couple of other folks that are there in this meeting. Invite, that's Amanda Murar. She's part of the product lead for the instrument integration in the manufacturing division. And there's Jim Yocho, who's our data strategist. All right. Let's move on to the next one. All right. So we used to have a lot of complex systems before this rollout of this new instrument integration strategy, where we used to have a lot of manual processes, people-dependent processes, and over a period of time, like in the past few years, we tried to move away from all those manual people-dependent processes into more computerized system-based processes, where we have more less manual transcriptions, more system-to-system transcriptions, and things like that. But thing is that as we started implementing a lot of these digital systems, now we are in a point where there are a lot of digital clutter that's aggregated. Like previously, analysts used to go to 10 different sheets of papers to do their analysis. Now they're going to 2 to 3 different systems to do their analysis and things like that, which is not so efficient. Let's say when you take it in terms of an analysis where you're supposed to log into 3 different systems to complete it, you're adding like 2 to 3 minutes every task or every analysis. So when you multiply that by number of tests an analyst do, and over the period of time, when you look at the entire numbers in the laboratory space, that number is very huge. It's millions and millions of minutes across the organization. So we're trying to minimize that by implementing certain systems and certain strategies here. I'll go over some of the strategy in the next slide, especially from an instrument integration point of view. Okay. So in a future process where what is the main idea that you want to go to is that we would like to have an instrument integration strategy where we only integrate standard systems, like controlling what sites can purchase, what labs can purchase. Is instead of proliferating, different models out there, we define set of standard instruments across the entire organization, especially in the manufacturing quality labs. Other organizations have different strategies. They're similar to ours too. That's one way of achieving the ideal state is, okay, let's say you wanted to buy in a spectrophotometer. Okay, we will probably provide you like 3 or 4 ideal instrument models that fit the business use or whatever it is after consultation with business case. So we have implemented strategies in this space. related to different instrument models, and we would like to expand that to other instrument models. So that's one of the key success factors that you'll see, because let's say in a lab, you might have 10 different models and you would like to integrate it and convert it to Allotrope. Converting Allotrope it'll become easy, but when you're talking about integration, end-to-end integration, it'll face a little bit of challenges in that space. All right. So as I already told you, currently the challenge statement is that system integration is designed around not letting people do manual transcriptions, but we would like to move from the manual transcription into designing integrations more around user experience. Like how can we make sure the analyst that's running the experiments has more seamless experience instead of feeling them like, hey, we're going to put multiple layers in front of you and make them frustrated about a change. That's where they will start not they will kind of become in a silo, and they'll not accept a new change. Like you might have resistance whenever you're doing change management and things like that. So that'll help us in that space. So another thing that I want to mention here is that if you see the first point is the P2P integrations, is because currently we are using a lot of point-to-point integrations from LIMS, because LIMS being a very custom built for every organization, it is very challenging to do integrations from LIMS directly to, let's say I want to do an integration between LIMS to a certain system. It is very challenging instead of master data changes, because master data changes are very change heavy. Like, you cannot do it that frequently, especially in large organizations, because you have a lot of these legacy processes and things like that. So we would like to lean out that process or that layer and bring that changes down into a different layer, because that's where we will have more flexibility to play around with all those changes and things like that. Okay. And as I already informed you, like we're only going to integrate global standards. That's one way of making sure you're scalable. Let's say I've done integration at one site. I have 12 different sites. All I need to do is cut, copy, paste. Like your scale up will be much faster and much rapid, instead of waiting. Like, because if you start entertaining non-standard instruments, now you have to customize the solution to every site, and every lab will have its own process. It'll become very difficult to scale up and things like that, because we had some experience in this space when we deployed other systems. So we would like to bring those learnings into this new program and see how it's going to work. Okay. So this is a very high level architecture. I couldn't share the detailed architecture with you today because our legal doesn't allow you to share all the things. So this will give you a good idea about how we are envisioning our future layer. Is because all of the 1 and 2, the data sources, these will be either the instruments or instruments controlling systems that will be in the laboratory space or at the site level. And there'll be a unified integration layer. This can be of multiple different applications, and that's a tech stack where that is used for standardizing, parsing, and converting to Allotrope. That's a layer where we convert it into Allotrope. I'm going to show a demonstration on how this is going to work today. We have some quick couple of examples that I'm going to share with you. And on the top side of that, or not of that, you'll have the LIMS layer, which is one of the source system, or like consumer of the data that is getting generated in the lab floor, and then one is the data like where we store most of our ASMs at this point. Okay. So why Allotrope? That's a most important question. Why not other data standards? So everyone is familiar with this Allotrope structure. I'm not going to go detail into it. So the only thing I'm going to tell you is, like, let's say, let me give let's say if I give this structure or this piece of information to anyone in the lab, the data is self-describing. So anyone can look at the data and, like, he can tell, like, hey, this is run on certain instrument. It looks like it is an analysis. It's run on for the certain batch number. So the data is self-describing. Anyone in the lab without a prior knowledge of that data set can look at it and tell that, like, he has used X or Y instrument to run this, and so the data is self-describing. So the contextualization is present within this Allotrope document. So that's why we adopted this standard. So okay. So Another reason for this is that adopting Allotrope is because since the Allotrope model has both data and contextualization built into it, it is a right candidate to put it into a graph model, because graph model is better in terms of because it's a text-based model, so its LLMs are much capable in reading text at this point than a tabular model. We have done some POC work in the space to see how an LLMs can understand tables versus like text-based inputs and things like that. So it's very easy for us to train a JSON structure document than put information in the form of tables, because currently the models are not good at understanding relational tables and things like that. There are specialized models out there that are currently can do some things in this space, but there's no like commercially available at this point. So most of our internal models are based on the commercial models. So commercial models are good at understanding text space. Yeah. So why graph? So if you get a look at this, because if you want to do queries across millions and millions of data sets that we have, if you do on a traditional SQL, it is very computationally intensive. And because everything is stored in the cloud, when you're talking about computing power is money. So the more amount of compute you do, you get charged for it. So your query should be very effective in retrieving the data, so that your end of the day, your cloud bill will be very much smaller. So if you look at the small query where we are looking for an analyst named Kumar, what are the analysis he has done. So you can see the clearly difference between how it's gonna be on a SQL query versus how it's gonna be on a Cypher or graph query. This is native to Neo4j. If someone knows about Neo4j, so this is not like a regular graph. It's very specific to Neo4j. There are other Gremlin and things like that AWS uses, but this is one of that language. Okay. So this is another large example where if you want to look for a sample identifier and in two different documents or two different analyses, one is related to weight, another one is related to empower. So you can see how the queries can be smaller. Okay. So this is one of the snippet from the knowledge graph that we developed using Neo4j. This is a very tiny data set, probably like this has like close to 20,000 records, I guess. But this is synthetically generated data, so it is not a actual lab data at this point, but it is synthetically generated using the LLMs. So which is like simulating the data that is in the, you give LLM like couple of sample files, and it's going to generate all the synthetic data using which we developed this knowledge graph to understand, what are the limitations and different patterns and things like that. So if you look at this knowledge graph, one of the key input for this knowledge graph is the ASM. So if you guys see all the ASMs that we are storing in our S3 bucket, we have a Lambda script using which it gets ingested into the Neo4j. This Neo4j is currently a standalone installation, so it's not production installation. So we have done work until this phase, along with the last piece, which is the consuming of the knowledge graph. So there is some POC work to be done in that space at this point. And another thing that where we want to leverage Allotrope is bringing the Active Directory data or the user information in terms of using Allotrope ontologies into the knowledge graph, so that the data can be can be enhanced. Like let's say I want to know a person reporting to XYZ manager. I want to know all the data that is generated by his reportees. So currently, it is not possible with just an ASM, because that reporting structure is stored within your Active Directory or things like that. So you need to bring in that data into using a common ontology into the graph database. So there's some work being done in that space too. Probably we might be able to share that probably in the next year or so. Okay. So I'm going to have a quick demonstration that I'm going to show you guys, where I'm going to, assuming I'm an analyst in a lab, and show you how data can be, generated and flows back and forth. So I have my limbs. Let's assume this is our execution layer. An analyst will walk into his limbs screen, and he has his sample ready, and he has logged the sample. And when he's ready to execute a task, he's gonna come here, and he's gonna transfer the results or create a task. This is still a POC, so the verbiage is still not accurate. But what is in this step he's doing is that he's creating a task, and this task is getting created on that instrument using the backend application which we use is Cytora DLX as a platform. So once the task is created, if I come into the screen, I should be able to see my task ready. So the analyst doesn't need to go into any other system. He just needs to walk into the instrument. He's going to log in with his Active Directory. So he has a single user ID and password. He doesn't need to remember multiple different user IDs and things like that. So you guys can see the task is already here. It's waiting for an instrument for the analyst to execute. So you can specify on which instrument the task can be. You can even specify who can execute the task. So you can do different kinds of limitations and role-based, restrictions on how this can be achieved. Okay. And once he's going to click this task, he's going to start the task. There's a simple pH adjustment method that I'm going to run to show you guys. pH adjustment is just used to adjust a solution pH. Let's say, he needs to make a pH or a buffer solution of 6 pH. So he's gonna measure the initial reading, and then later on he's gonna reduce it using acid or base and things like that to achieve that whatever the solution pH he needs. Okay. So okay, I'm gonna take a manual endpoint, initial reading. Let's say the initial reading of the solution is 10, and then he's going to start adjusting. He's going to add some acid and bring the pH down. And let's say the solution needs to be at 1 pH. He's going to take that. And when he's done, that's it. And he's going to exit the instrument. He's going to go back to his execution layer. In another couple of minutes, if I refresh this page, you should be able to see the data getting populated, like how it got populated here. So that is an automated process. So it doesn't need to wait for a signature or anything like that. At this later stage, the second person will go and review the source information in the source system and things like that. But along with the same process, what happened is that if I refresh my S3 bucket here, the orchestration has generated an ASM, and it has placed that ASM into this bucket. So if we see, I should have my ASM in here in a bit. So this is a balance one. Right. So if you see here, it has placed the ASM object into the bucket. It's still named as balance, but no, doesn't work. It's fine with that. Let me download it and show you guys. So you get an idea of like what is the process going to be in a production system. So that's our ASM bucket. ASM that's generated for a pH adjustment. So like that, we have done some work with like close to chromatography balances, pH, and different types of metal Toledo instruments, along with some osmolality and things like that for our POC. So all these ASMs will be ingested into that Neo4j database, the graph database. Currently, I don't have approval to show you show anything in that space, but probably like next time we might get something or to show you guys in that space. All right. So what are our next steps? Where are we in this whole journey? Right now, if you see, we are currently in the proof of concept state. We're currently planning to complete that in the next 2 weeks or so, and we're going to do a readout in early Q1. We're planning to roll out to the pilot sites with the initial set of instruments. Okay, and there are some key action items that are coming out of this. One is that we still yet to figure out RDF versus LPG. This is some internal discussions needs to happen in that space. That's mostly the digital services that take care of that part, which is a different organization in our company. And finalize. We have to still figure out a couple of the things and where we want to store ASM schemas and things like that. And we are still working with some of the manufacturers to see if they can directly output out ASMs from their instruments, because that's where we want to ultimately go. And along with that, we're working closely with the Allotrope Foundation, be part of the working group, and contribute to the other models that currently doesn't exist with the help of our SMEs in the lab or our research scientists and things like that. All right. Any questions?